What if the Earth was tidally locked to the sun? Imagine a world where, instead of a spinning Earth, causing the beautiful cycle of day and night, one side of the planet forever faces the sun, bathed in perpetual daylight, while the other is lost in unending darkness. This is the scenario if Earth were tidally locked to the sun, a state in which the same hemisphere of the planet always points toward its star. As strange and far-fetched as it may sound, this sort of gravitational relationship is not uncommon in our universe. Many moons are tidally locked to their planets, and planets orbiting close to their parent stars, such as some so-called exoplanets, appear to always show the same face to their sun. But what would this mean for life, climate, and the balance of our world? How would landscapes, weather patterns, and even cities form if daytime and nighttime no longer alternated, but instead became permanent features of geography? To answer these questions, let's embark on a journey tracing the consequences and changes that would ripple through such an alternate Earth. We begin by considering our current situation. Earth rotates on its axis every 24 hours, causing the sun to rise and set across each region of the planet. This efficient spin not only drives our familiar pattern of day and night, but also helps churn the atmosphere, mixing energy and aiding in the distribution of heat. Tides, winds, currents, and weather all stem in part from this ceaseless motion and the differential heating it drives. Now, let us imagine our world's rotation gradually slows down until it halts with respect to the sun, an astronomical process that would take billions of years, if it were to happen at all, due to the tidal forces between Earth and the sun. Once tidally locked, the Earth would complete one rotation per orbit around the sun, meaning a day would last as long as a year. The sun would hover fixed in the sky for some locations, never moving, casting unending shadows or light. For others, the sun would remain perpetually below the horizon, never shining, save perhaps for the faintest twilight near the boundary between day and night. The most immediate change would be the division of our world into fundamentally different realms, one of perpetual day, the other of eternal night, with a narrow band, the so-called terminator, lying at the edge, trapped in an everlasting twilight. Let us step first onto the day side of this new Earth. Here, the sun would blaze from a single spot in the sky, never setting, scorching the landscape below. This would not be just any ordinary summer day. The unyielding rays would heat the ground, oceans, and atmosphere relentlessly, with no respite. Temperatures would soar far beyond anything our daily rotation currently permits. As the continents baked, vast deserts would unfurl, dust wrapping itself around the hot, dry winds. Cities, as we know them in our present era, would be nearly impossible to sustain close to the subsolar point, where the sun lay directly overhead. Day after day, with no break for cooling, the surface temperature could climb to extremes only matched by the hottest deserts of today. Or worse. Water would evaporate quickly, soil would dry out and crack, vegetation would wither, and only the most resilient or well-adapted life forms could persist. If any rivers existed, they'd be reduced to mud or trickles, their sources unable to replenish in the merciless heat. Yet the story is more complicated than a sun-baked wasteland. As we move away from the subsolar point, the very center of the dayside, conditions gradually moderate. The angle of sunlight softens, temperatures begin to drop. Along this radial gradient, climate zones might form broad concentric bands, with the hottest desert at the heart, grading into dry savanna, then temperate rainforests nearer the terminator. Plants and animals would find precarious homes at these edges, where sunlight, warmth, and water could coexist in just the right ranges. Somewhere near the terminator, the perpetual dusk would offer the closest approximation to our familiar earthly world. Here, neither scalding heat nor absolute cold would dominate. Many animals and plants could attempt to adapt to this region of constant twilight. Human settlements might cluster along this border, their streets bathed in a forever evening hue, their economies and cultures shaped by the perpetual suns on the horizon. Agriculture, if possible, would concentrate in these narrow strips where water might still flow and where moderate sunlight could support photosynthesis. The idea of a city by the sunset line takes on a new meaning. Not a fleeting glimpse each evening, but a permanent, living edge. What happens, though, to the side that never sees sunlight, the eternal night? This hemisphere would be in the thrall of permanent darkness, illuminated only, perhaps, by the faintest glimmer of starlight or auroras energized by the solar wind. Without sunlight to warm it, the nighttime face would rapidly lose whatever heat it receives, plunging into deep cold. Oceans and lakes, without any source of warmth, might freeze solid, locking up much of the planet's water in impenetrable ice. The land, too, would freeze, permanently, deeply, perhaps rivaling or surpassing the coldest places in our solar system. Would life be possible here? Not in the forms we recognize. Without energy from the sun, plants could not photosynthesize. Animals that rely on plants, in turn, would vanish. Any life would have to survive using geothermal heat from inside the planet, clustered around volcanic vents or deep underground. Unique ecosystems might develop, analogues to those found at Earth's deep-sea hydrothermal vents, but the cold and absence of light would make this a far more barren world. However, the boundary between day and night, the twilight zone, would not be a simple static line. Here, temperatures would transition sharply, and atmospheric dynamics would ensure that winds and weather would be far from still. In fact, one of the most dramatic consequences of tidal locking would arise from these immense temperature gradients. On the sunlit half, air near the surface would become intensely hot, rise, and create a region of low pressure. On the night side, frigid air would sink, increasing pressure. This setup would drive enormous winds, attempting to redistribute heat and restore balance. Jet streams might howl endlessly from perpetual sunset to permanent sunrise, transporting air masses, dust, and possibly even moisture. Vast storms could rage, their intensity determined by the contrast between night and day. Clouds, too, would act differently. On the day side, water vapor rising from whatever sources remained could form dense cloud decks above the overheated ground. These clouds could reflect some sunlight back into space, mitigating the worst of the heat beneath them. On the night side, any moisture that managed to be transported from the day side would fall as snow or sleet, adding to thick ice caps, only to be removed subliminally in the rare cases the air currents reversed. Over millions of years, a slow transfer of water from the hot side to the cold might occur, drying the sunny hemisphere and worsening the ice and aridity of the night side. Earth's magnetic field would continue to play a vital role, shielding the planet from the solar wind, but the atmospheric circulation patterns would be fundamentally altered. The Coriolis effect, which shapes our current west to east planetary winds, depends on a rotating, spinning world. On a tidally locked Earth, the atmosphere would circulate with a new geometry, defined by the ceaseless push from hot to cold, sunward to anti-sunward. Weather systems as we know them might be replaced by gigantic, stable wind cells stretching from the subsolar point to the anti-solar point, with great rivers of air perpetually flowing. The oceans, too, would change form and function. At the heart of the day side, the sea would evaporate rapidly, perhaps leaving behind dried salt flats, while at the night side, thick continents of ice would encase once temperate seas. Only on the terminator, where neither state holds absolute sway, could liquid water persist. Here, perhaps, vast rivers and lakes collect the runoff, their flow always westward or eastward, never following the rhythms of rain as before, but instead tracing the immovable border between worlds. Human societies would need to adapt dramatically to such an alien environment. The resources available to them, sunlight, water, habitable land, would be limited and precious, concentrated into a thin band at the edge of night and day. Cities might hug the terminator like pearls on a necklace, cultures mixing and separating along lines not of latitude and longitude, but of perpetual shadow and sunlight. Language, myth, and meaning would be profoundly shaped by the unending sky above. Stories built not around sunrise and sunset, but around eternal dusk, transition, and the inescapable reality of either light or dark. The biological clock, an ancient rhythm beating in all living things, would need to adapt or disappear. Humans might come to rely on artificial light cycles, imposing a simulated day and night to preserve sleep and waking. Animals that migrated, once following the seasons, would find new routes or die out. Plants would struggle or flourish depending on their place in the sun's geography. Some species could evolve unique mechanisms to cope with the endless light or the ceaseless darkness, perhaps inventing new ways to capture or conserve energy. Over deep time, even the rocks and the land might change. The wind and water on the day side would erode mountains quickly, transfer dust to the night side via planetary-scale winds. Ice sheets on the night side might grind down continents, glaciers reaching thousands of meters in thickness. Volcanoes could, for a little while, offer flickers of warmth and power in the darkness, but without the endless cycle of water and life, even the land would transform, dry, cracked deserts to one side, icy wastelands to the other. It's even possible that, as heat and moisture migrate over eons, the planet might become two distinctly different worlds, each with their own unique geology, one parched, sun-blasted, the other a continent-sized block of ice. The very structure of time would evolve with such a world. Our ancestors marked hours by the passage of the sun, measured seasons by its height and strength. On a tidally locked Earth, these measures lose all meaning. For most, the sun would not move. Days and years would blur into one. Calendars might be pegged instead to the subtle shifts in the distant stars, lunar cycles, or the slow passage through points in the planet's orbit. The cultures that grew up along the Terminator might track time by weather patterns, the coming and going of wind, the rare changes in cloud cover, or the ebb and flow of whatever water remained. So, too, would maps reflect new realities. Instead of north, south, east, and west, the whole world's orientation would be dominated by the sunward and anti-sunward, anchored at the unwavering sun or its absence. Cartographers would chart landscapes not by the spindle of the poles, but by the arcs of light and shadow, the breadth of twilight that circled the world. Would the planet sustain life at all? The answer would depend on delicate balances. If the Terminator zone proved wide enough and heat-to-cold winds managed to moderate conditions, it's possible that a narrow Goldilocks strip would remain. Here, perhaps, forests could gather in the shrouded dusk, rivers might run in valleys, and animals could browse in the shadowed woods and grasslands. Evolved to tolerate everlasting sunset, these creatures would adapt to a world where the light never changed, where time seemed to stand still. Yet this balance would be precarious. Small shifts, changes in the orbit, atmospheric composition, or the sun's output could tip the entire arrangement toward one extreme or the other. A slightly hotter sun could push the habitable zone backward, squeezing life toward ever narrower stripes of comfort. A slight dip in heat could allow encroaching ice to swallow the twilight. Tidal locking could also play tricks with the planet's magnetic field and tectonic processes over vast timescales. Without the dynamism of constant rotation, the churning in Earth's outer core, which generates our geomagnetic protection, might slow or evolve differently, potentially exposing the planet to more solar and cosmic radiation. This could influence evolutionary outcomes or threaten life altogether. Looking beyond Earth, we know that many exoplanets discovered so far, especially those close to their parent star, are likely tidally locked. For these super-Earths and hot Jupiters, life would have to face the same extraordinary challenges. Scientists have pointed out that even in these conditions, the twilight band may remain the best chance for habitability. It's become a guiding principle in the search for life. Look not just for Earth-like planets, but for regions on these planets where the balance of light and heat might allow life to persevere. Returning to our own Earth, we recognize how fragile and necessary our current system is. The balance of day and night, the march of seasons, the continual mixing of sunlit warmth and polar cold. These are not casual background traits, but the deep engines that sustain every living thing. Every breath of wind, every drop of rain. The diversity of environments from deserts to rainforests, jungles to tundra, depend on this spinning, dynamic globe. In the absence of that rhythm, the world's features would become stark and uncompromising. Perpetual day, unending night, and a sliver of possibility in between. Yet, even here, in the midst of change, life might yet find a way. On the twilight edge, New forms of organization and biology would arise. Plants that face the sun from angles never shifting might develop leaves more vertical, less subject to the risk of burning. Animals would take up lives of endless dusk, their senses fine-tuned to ceaseless twilight, their routines structured around wind, water, and the perennial position of the sun sitting unmoving on the horizon. Human culture, impressively adaptable, would respond as well. New mythologies would tell of the boundaries between the realms of day and night, explorers driven to cross the ice into the endless cold, or scientists venturing into the burning heart of the light. Spiritual traditions might sprout up around the immovable sun, the line of dusk, the power of shadow. Technologies would have to evolve. On the day side, cities would demand advanced cooling to survive, structures shielded from constant solar fury. Water would become ever more precious, pumped from deeper aquifers or perhaps imported from the ice sheets of the eternal night. Solar energy would become abundant, but only valuable where the temperature could be carefully managed. On the night side, habitats would burrow deep, huddling with geothermal warmth, perhaps mining the cold itself for novel applications, or drawing energy from difference in temperature between the worlds. Transportation would take on new meaning. Arctic caravans ferrying ice, desert ships transporting rare crops from the dusk, trade routes winding along the rim where life is possible. Can we imagine art and expression in such a world? Painters and poets basking in the unvarying colors of dusk, orange and purple horizons locked forever in place, the stars smeared permanently into one side of the sky. Musicians writing lullabies to the never-ending twilight, or pulse-pounding anthems for those who dare the journey toward either eternal sun or unending shade. The sciences, too, would be transformed. Astronomy would be best practiced on the night side, where telescopes could look forever at stars without sunlight interference. Agriculture would be a science of location, tracking gradients of temperature and shadow rather than time. Meteorologists would model winds of vast, uninterrupted strength, perhaps even predicting stable, forever storms at the boundary where cold and hot collide. One could debate whether evolution would have led to intelligent life at all on such a world. Perhaps the harshness and stability would thwart the creative pressures and variety that fostered our rise on variable, cycling Earth. Or perhaps the struggle would produce new forms of intelligence, adapted to twilight, comfortable in the in-between. Considering a world like this, the Earth eternally facing its sun, divided into hemispheres of fire and ice, reminds us of the delicacy of our cosmic balance. Every sunrise, every gentle nightfall, every change of season is a gift of dynamism that our planet alone, among the nearby worlds, uniquely enjoys. The familiar turning of the globe is not just background for life. It is the source of all that makes life possible. As science continues to explore the universe and we imagine new worlds, both real and hypothetical, we are reminded of our world's place in the cosmos. The dream of Earth as a tidally locked planet stirs us to contemplate existence on a razor's edge, between extremes, in the temperate middle, adapting, surviving, and thriving wherever the balance allows. In so doing, we gain new appreciation for the riches afforded by our spinning sphere and the cycles by which we mark our days, our years, and the precious, ever-changing seasons of life. Thank you for watching the video. What do you think about today's topic? Feel free to share your thoughts in the comments below. If you enjoyed it, don't forget to like and share the video to support the channel. Thanks again, and see you in the next video.